Hello guys, my name is Adrian and welcome to my channel. If you are new to the channel, I am trying here to create a small framework in order to be used for some game that I am developing live on stream. So far, we took care of the window creation, input, events, and all that stuff, and we started our journey with OpenGL. We talked about the buffers and the vertex array, and now it's the moment to talk about shaders. But before talking about the shaders and actually create some shader, we need to do some work in order to be able to load a file. This is a very critical step. Why? Because shaders mostly are something similar to a program that is running on the GPU. So how does work? Most of the time you are creating some files that you are writing some code that is similar in syntax with C, especially for GLSL, the language responsible for OpenGL. And what you need to do, you need to take that code that most of the time exists in a file, and through some functions you are sending to the GPU. But today we'll take care just about the reading from a file. In the next videos, we'll talk about how to create the shaders and so on. So, in order to do that, we will start working on a new module. It is called resources. So, in order to have this thing like working a little faster, I will just open a CMake here, for example, and we'll start first. In the resources, we'll add a new folder called core, similar with all our modules. Of course, in the core, we're adding the CMake file, and I'll create also a new class called file. Another file, it will be headers, where most of the time I'm just putting things that are like, for example, include, in our case, because we will do something about the files, we will have something like include fstream. This is the header responsible for file reading. We will need, of course, the vector, because what we extract from a file, I want to put it in a vector, and what we can have. Another thing is CAssert, because we want to do some asserts, like if the file was open or not, or if it's missing, and so on. And I will make use also of the file system, which will help us to create paths and so on for our file. Okay, first, because I said that I want to move a little faster today, I will open, let's say, as an example. Inside our core, of course, we want to have the include directories with the project name, and this is kind of the dot, which means that we will be able to make like include core file when we need the header for the file. Of course, target precompiled headers, is the place where we put, of course, the std headers, and the last of it, target sources, project name, public, and file cpp. Later on, we will kind of align these things. And another thing that we need to do, of course, here it's the project, and we'll call it resources module. It uses C++ as the language. We'll have this add library resources module. If you have any questions about this thing regarding mostly of CMake, you can write the comments. I'm pretty active in that area, so don't worry if you have a question. And of course, we are adding the core. I'm moving a little forward to this process because we did it already in previous videos for both platforms and for graphics modules. So, okay. What it remains for us, of course, we need to go in here and have the resources module included and compiled. It should appear also here. So if we are running right now, nothing is really happening. Okay, what we can do further, we can go here into the core and include core, and let's have the file speed. Of course, let's sort these headers and let's make a run to see that everything is set. So now what remains for us is to make the implementation for this file, nothing more than that. So today we'll take care just of the, for example, for the file, we'll take care just about the reading. Later on, at some point, we will do the writing, but for us, the important part for the shaders, it's the reading. Why I put the file class inside the resources? Because here the file class it will be used. We'll have other, let's say, files that needs to be read, not just the shaders. We will have at some point, for example, 3D models, textures, and so on. So it makes sense to have the file into the resources. I have also a common module, but the commons module will be used for math and other stuff. Okay, so let's continue. First, I want to delete the constructor because we'll not be able to have instances of this file class. After that, static auto read, and I will have a constant std file system path, and I'll call it path, for example, and I'll have an int32 type, which I will call mode, and I will leave it initialized with 0. Okay, and at the end, of course, I want a vector of characters. Okay, or if we want, we can have UI int 8, doesn't matter in the end what we are putting here. We can let it with UI int 8 to see how it's working. If we'll have any problem, we can change it. But if we are using char, for sure, probably will not need to do some casting there, because by default, when we are using the app stream, something that is supported out of the box by C++, okay, is the, let's say, the C++ way of reading a file most of the times. The information that is kind of, or the information that we get from the stream, it's with characters. So if I'm using UI int 8, which in fact it's also a character type, I need to do a cast. So in order to avoid the cast, let's keep it like this. Okay, so what we are doing further, we will start with an assert for sure that it's called its regular file, and we will use the path. Okay. After that, we will try to, let's say, I will call this stream, of course, and we will try to open a stream at the path, and as the flag, I will use AT, which will mean that it will open the file at the end. Okay, that's the most important part. And after that, I will make here some byte operation with the mode. Okay, so in case we wanted to read it binary form, we need to specify this outside. Okay. After that, let's make a short assert that the stream is open. Okay, it's very important. In some other implementations, people are doing try, catches, and all that stuff. I prefer it for now, in the beginning, to have it like this. It helps me a lot with the assert, because when I'm missing some file or something is wrong, is not open, or so on, it will crash directly. So that's what I kind of really want during the development. Constant auto size equal with the stream, and we have this function tell g, which will kind of give us the, let's say, the size. It will kind of show us where the, because if you remember, we passed here the flag ATE at the end. Okay, this is the name at the end. This telg, it will give the position of the cursor, imaginary cursor, let's say, or the reading cursor. So it will go at the end, and this is how you kind of get the size of the file. Of course, we need to do an assert that the size is bigger than 0. Okay, we don't want to do something with when the file is kind of empty. Other than that, we kind of create a vector of characters, sorry, content, size. So we are pre-allocating this with the size. After that, we call this function stream sigg with 0, and we are moving the cursor at the beginning. Okay, so this function will kind of move the cursor at the start. After that, what we need to do, stream read into the content data pointer, okay, the one that we have from here, and we need to specify the size. Other than that, at the end, we can return the content. Let's try to kind of build this code. This will be a little, let's say, a smaller, not tutorial, but a smaller video. What we can do further, let's create a base, for example, how to call it, base shader. Okay, we'll put the extension vertex from the vertices. Okay, let's create another one, base shader frag. And in it, what we can do, I will just write void main, something like this, just to not have the file empty. Sorry. I will copy this and put it into the other one. Okay, and what I will try to do further, it's kind of very simple. Let's see, somewhere around here, let's have an auto. Okay, and let's call it base shader vert. Okay, equal with the core file read, and we will try to use base shader. Sorry, it will take string, and let's have base shader vert, and let's duplicate this. Let's change this to frag. Okay, and what I will want to do further, I will run this into the debug mode to see whatever we are getting from these files. Okay, so it seems that we are getting something like void main. Okay, the same applies to the second one, and let's make a test into the fragment one and rerun and see if the garbage that we just put there, it's there. So we have it. Just a second. You see, we have it like this. So the file reading, it's working. This will kind of be a very important step when we will do in the next video the shader creation. When you are creating a shader, you need kind of to give some code to it. Like I said, the syntax will be similar with C. Okay, or with C++, let's say. And what we need in the next video, it will be to first create the shaders and the program objects. Of course, I'll give you more information about those. But other than that, it will be just to use this information that we are getting from the files, create the shaders, and our, let's say, black square, it will become whatever color we will choose to have in the shaders. So for today, this is what we have. It's very important to have a file class that can help you to read some information from a file. Like I said, later we'll have the write function, but this implementation of the file, it's kind of, for the file, it's kind of one of the most, let's say, faster ways of reading something from a file. Okay. At some point, if this is not optimal and it will kind of be a problem for us, we will change it, and of course, we'll try to make it faster. But for now, it will do the job for a while. Thanks for watching. If you're new to the channel, of course, subscribe. It's a good choice to be, let's say, up to date with what we will put here. And if you like the video, a like is very appreciated. If you have a comment, don't worry, I'm pretty active, so write me, ask me any question, and I will answer. Have a nice day, and see you in the next video. Bye bye.